family testing. I don't know. I guess
So we went to JP. It's like
Florence area.
Oh no, it's Vermont.
Oh, it's in Vermont. I'm going to Stratton this weekend.
Oh, you are?
Yeah.
Stratton's close to Vermont. I think we're gonna try and go to chemo, which is like someone that.
I'd rather like for one.
The lesson, the lesson of JP is just 5.5 hours, included lunch. And it was like and that's like an Olympic. So right, the people who are doing the lesson are like ex-Olympic skiers.
Right.
Yeah. Okay, class in session now. Welcome back to mechanical and electrical equipment class. Today, it's a pleasure to have the guest lecturers with us. So as it has been announced, our guest lecturers are going to talk about the Marshall Hall renovation project. So it's a pleasure to have Casey.
I'm Casey. Hi.
Quinn and Matt with us. So they're going to introduce themselves. And field is yours. So
All right, sounds good. Sweet.
I'll go first.
You want the clicker?
Yeah, I deserve the clicker. That's true.
All right. So my name is Matt Herbert. We'll introduce ourselves a little bit and then I'll kind of give us a little bit of a lead in on our wonderful journey that we're going to take with our heat pump hysteria. My name that I thought we should go with, but Quinn didn't like it. So my name's Matt Herbert. I'm a 2014 grad from the LA program. I've been in construction management since I was 18 years old. I currently am a project manager at La Chase, and I specialize in K-12 and higher ed public bid work. Quinn?
My name's Quinn Rowland. I'm with Pathfinder now. I gotta get used to the new name, but I'm a mechanical engineer by trade, project manager. I started in the industry as a structural engineer, then did energy for a while. Now I'm in mechanical. Seems to be where I'm landing and staying. Yeah, it's where I'm meant to be. Yeah, for sure. So, yeah, I've been in the industry for about 13, 14 years, somewhere in there.
I'm Casey Pendleton with Chang O'Brien Architects. We were the architects on the project. I've been in the field for about 15 years, just doing K through 12 for about 12 and then higher ed for about 5. So this was my first big project with Chang O'Brien at Marshall Hall. I'm working with these guys.
Yeah, you'll
Get it done.
You'll have to excuse some of our banter. We've spent the better part of 3 years together.
We've been through some stuff together.
We've seen some things together. So Marshall Hall was a GC Prime SUCF bid. What that means for all of you is that there was one contract. Everyone was through the GC. All other subcontractors, HVAC, electrical, everyone was through the GC. With Chase, myself acted as the construction manager for the state, overseeing payments, work progress, safety, and all of the other things that come along with that. It's a CM agency for the owner. It's essentially someone on site to make sure that the owner is getting everything that they paid for. I started on the project in 2020. Casey had been there before, working on the preliminary design, getting things ready to go. Been there about since 2018.
Since 2019-ish. So I came in about the tail end of SD or DD, beginning of CDs. So the design was pretty much set when I got there, and I was just tasked with kind of detailing and completing, design and construction documents.
Yep, and I came on the project midway through construction. We had some turnover in our office, so it fell to me to pick up and come in during construction and make sure that it went together in its final stages.
So this is sort of the layout for our presentation today. If you guys have questions, we could definitely go through. We'll have stories and things that will probably pop up throughout this, just because it was about 3.5 years of construction that we were all together. We spent too much time together. So this is Marshall Hall as you see it today. And here is some of the historical context. So this is from the 1931 construction. Project was finished about 1932-ish. You can see the historic bridge here. Marshall was the second campus building. Originally Bray was the first one. This is Archibald Stadium that was demolished to make way for the dome. And if you've seen the little banner here in Marshall Hall or in the dome, it's because this part of the road is owned by the state. And so they had to work out a deal to be able to build it. And the chancellor of ESF at the time thought that the dome would fail. And so all he wanted was a little banner. Looking back, it's probably not the best decision anyone's ever made. And then we have the 2017, full campus, full quad, full everything. And how that sort of all comes together. Marshall Hall has a lot of historical context that went into its programming, and Casey and Quinn will get into a little bit more of the architectural programming, HVAC programming, how we had to put all that together. There was a lot of work that went into the historical context of the project to try and bring it up to today's codes and today's standards. It was a long process that took a lot of doing.
I'll take it. Thanks, Matt. Hi, everybody. So, Marshall Hall was a pretty big project, 90-ish thousand square feet with the addition of the stair tower turned into almost 100,000 square feet of renovation and addition space. So with any project like that, you have to go through a programming process with all the people involved, kind of determine program, also just general goals and visions for the project. So here are some goals that were determined early on. The identity and visibility for each program. So in this case, it was the landscape architecture program, the environmental studies program, the general education program. I don't know if any of you were there or saw Marshall Hall prior to renovation, but it hadn't been fully renovated since 1933. So it'd been about 70, 80, even longer years since renovation. So all the teaching spaces were from 1933. The technological upgrades, aesthetic upgrades as well. Landscape studios were just kind of jammed in an old library space, not really suitable for today's teaching environment. Another thing that was very important to the campus was accessibility. I know you guys know that there's some elevation change present on this campus. And there was no way to navigate from the level of Gray Hall all the way down to Jan Baker on the wheelchair. This wasn't possible at the time. So we were tasked with figuring that out inside the building and on campus itself. Marshall is also a very historic building, mostly located in the main lobby. If you go into the main quad doors, all that's original woodwork, terrazzo flooring, ironwork. So we were tasked with maintaining that as much as we possibly could. And then also HVAC systems, well, which we'll talk about a little later. So this is a diagram kind of how we got about sizing and numbering of, in this instance, classrooms within the building itself. So you can see we have enrollment numbers for fall 2000 to fall 2019, number of classes enrolled in particular class sizes. What we determined, this row right here was the existing number of classrooms in Marshall at the time prior to renovation. So you can see there was more of a need for 1 to 30 size classrooms as opposed to 32 to 50 classrooms. So these were too many. This was undersized. So we needed to adjust the number of and sizes of classrooms in the building to accommodate today's teaching needs. We use these kinds of tools generally. So this is a bubble diagram that represents space of each type of space within the building, also color coded by department. So each color represents an apartment. Each circle represents a particular space within that, whether it be a office, a seminar space, something along those lines. And they're all proportional to each other. So these proportions represent their relationship in square foot. So once we get kind of an agreed upon program, we start grouping these and associations and critical and desired relationships. And then we start placing those into the building. And we try to maintain those relationships as much as we possibly can throughout the process. Obviously, nothing's perfect. People have to make concessions, but we do our best to maintain those critical relationships. And it's also a collaborative process all through the design process with everybody involved. Everything is a committee. So committee, it's great. So, accessibility, so you can see here, this is a section through the entire site, going through the quad here. Marshall right here, Jan, Baker, where we are right now, and Bray Hall. As you can see, this elevation change we were not able to navigate that by wheelchair. This is a site plan as it stands today. East side, we have a stair tower along with this new switchback slope walk, which is ADA accessible, so a wheelchair can navigate from this level all the way up to the quad level. You can see these pillars for the bridge to Bray over here, which was not originally going to be part of the project, but we snuck it in as an alternate during the bid. We were under budget, and they took some alternates during the bid process, so we got to keep the bridge to Bray, which completed the ADA access from Bray all the way down to Yon. So here's some pictures of the original entrance here. So this is the east side. Stair tower is located at this location today, right here. This is the original entrance. You can see the parking area was lower. There was this ramp going into this cavernous recess by Nifkin, really not inviting at all. So we decided to raise the level of the floor here to the level of the basement and add this glass canopy in to just introduce natural light and make it more inviting. And then you're probably all aware of the stair tower that's there as well, which houses an elevator and stairs. So people in wheelchairs can access the site. This is the switchback. So this is a slope walk, not a ramp, which is very important. We didn't have to put handrails there. I think 1 to 50, 1 inch over 50 inches is a slope walk, and then 1 to 20 is a ramp, which would then need handrails. So that's why this is so long, cutting back and forth, prevented us from needing to put handrails into the project. And you can see the existing condition here, obviously not wheelchair friendly. Original pictures of the prior renovation here quad side. You can see there were 2 double doors in each of these openings. Each one was not big enough to comply with ADA. So we decided to put a single door in, and we also increased the depth of the interior vestibule here. You can see the dashed red line is the original location, and then the black line pushed back to meet ADA clearances is in black. One of the final pieces here is the bridge to Bray, which completes the kind of ADA access. You can see that here, a little quick sketch here. And what's interesting is during construction, they actually built a temporary bridge to Bray thing to get construction materials into the building, and then removed it once it was done. But 100 years later, we put the bridge to Bray back in. This is the original east entrance under the bridge here. So the bridge is there today. You can see the original had stairs, which is not ADA compliant. We ripped that out and put it in ADA compliant. That completes the ADA of the building. We were also tasked with keeping all the historical where possible. Like I said, a lot of those details are in the auditorium. First floor doors we retained, refinished, reinstalled. The slate chalkboards we installed with new wood trim and marker or chalk trays. Original scroll work as well here. Refinishing of all wood components, and the existing terrazzo floor and phone booth in that area we refurbished as well. So wherever we could, we tried to keep those details. I'll talk a little bit about the HVAC system.
So as Casey mentioned, energy savings, making an energy efficient building, that's a big goal for this project. This fell under the deep energy savings retrofit. That's kind of a program that the construction fund runs. That's where it fell at the time. That goes through iterations all the time to keep pushing the envelope. Obviously, ESF is a very environmentally leading campus, so this was something that was important to them as well. And this is something where it's important to understand how the whole building functions together. I am a mechanical person. I'm putting things to heat and cool the building, but I care about every single component that goes into there because it affects my equipment. So what we end up doing with the windows, what we end up doing with the walls, what kind of lighting we put in, how we're scheduling even people or ventilation, like all of those things play together, and you can use modeling to kind of optimize that and make sure that your building is going to be run efficiently, make sure you can get your heating equipment sized correctly. All of those things kind of play together to get the best performing building at the end of the project. So we had quite a number of iterations going through looking at all of those various components to figure out what was going to go best into this project. As far as how we were heating the building, that was another big discussion for this one. The building was previously on the Syracuse steam system, and that was something that the campus knew that they wanted to get off of. One, you know, they pay for it, it's super inefficient and everything, and it just wasn't going to be meeting the goals for this building. So we looked at geothermal is where we would have really loved to be for this building. At the time of the projects just weren't being properly funded for geothermal. It's a very expensive system because, you know, you're drilling 500 feet into the ground. That's expensive. You're going to need probably for this building over 100 wells to serve it, and that adds up. So at the time of this project, we just really didn't have the funding to support geothermal, and actually the quad, which we had originally looked at, that's now going to serve ILIC as part of a new project that's, I think, currently starting up right now. So we knew we didn't want to be on steam. We knew we didn't want to be on geothermal. You know, we could have gone with some kind of electric resistance. The problem with that is that it explodes your service size. So the service of the building just wasn't there to support a electric system. So what we did is we ended up doing a high efficiency natural gas condensing boiler. It's one of the last projects that was allowed to put new boilers in the state. Moving forward, they said, nope, it's all electric from now on, which causes, you know, some issues with all of those things that I just talked about. The other thing with electric is if you want to be able to back up heat your building, you know, if your power fails and you want to heat it and you're on electric resistance heat, you need a really big generator, and that gets out of control very quickly. So anyway, that's kind of where we ended up with our natural gas boiler on our heat pump system. So I talked a little bit about it, but when we're looking at this, we really want to look at the building as a whole. There's a lot of goals that tend to almost compete with each other when you're looking at putting systems into the building. This was a hugely historic building. There was a lot of detailing that we were trying to preserve. It goes through a whole SHIP overview, which is an agency that literally just looks at your drawing and makes sure that you're following the historic detailing that they want to see for these older buildings, these older important buildings. Sometimes that competes with energy efficiency. You know, if they say you can only put windows in that look exactly like these existing windows, you're limited to your options. If they tell you you got to keep certain detailing, there's less things that you can do on the inside with ductwork or with equipment that might be counter to those goals. We have what we want to see as far as the room aesthetics and space constraints. Existing buildings are always tricky when it comes to renovations. Typically, they don't even have cooling. So now you're trying to fit AC in a building that was never built for that type of ductwork, was never built to support those types of systems. Half the time they have really small floor to floor constraints. And as you have to get creative with your routing and where you're putting your system. So one of the historic things, Casey talked about the entrance, that one historic entrance and what they did with the vestibules. So this is the final condition here, where the cabinet unit heater is actually hidden behind some very new casework that was really created to look exactly like what was there before, even though we were changing the dimensions. So a lot of times you'll see in all your vestibules, there's like a little piece of metal in the corner there, that's your cabinet unit heater that's heating that space. But in this case, because we were trying to be sensitive to the historic nature, we were able to kind of hide that. And then another important space was the auditorium. So we knew we really didn't want to be exposing something with that ceiling and the look in there. So we actually have linear diffusers up here that are shooting out the HVAC to the space. Yeah.
Those gas heaters.
So no, those are hot water. So I'll talk a little bit more about the system, but basically we have hot water distribution throughout. The gas is at the boiler, which is then creating those hot waters. So yes and no, there's not like a gas fired where like each one has a little pilot or something like you would on a residential furnace, but they are fed from a heating source that's natural gas because the boilers are doing that. which leads me to the mechanical system that we have in this building. So we wanted to have a cohesive system throughout the building. It was kind of a mismatch of what was there before. So the main system is a heat pump. So what that means is that you have a bunch of systems throughout the building that have a fan and a compressor. And then those are all tied into a hydronic system that really fluctuates in temperature quite a bit. It's allowed to float. And then the heat pumps use the compressor energy to either heat or cool the building. So even though we have those natural gas boilers, we're really pulling some of that load off of natural gas and using the compressor energy, the electrical energy of those heat pumps to heat and cool the spaces. So it really helps too when you're in like swing season, which is like spring and fall, where you're sharing load, summer and heating, summer and cooling. You don't need to add any heat to the system to get that heating because they're able to kind of share. One over here is in cooling and then one's in heating, and they share that energy between the two of them so that you're really not turning your boilers on unless like the whole building isn't heating. We paired up this system with the boilers, which we talked about a little bit, and then for cooling, you need somewhere to reject any excess heat. So what we have on this building is an adiabatic cooler. Basically, you pump your water up there, and anytime it's too hot, that adiabatic cooler has air fans that just move an incredible amount of air through a coil. And there's actually a wetted pad on the front of that that helps to cool that air even more, so that you get some of that latent capacity instead of just a sensible. So those are what are rejecting any excess heat from the building out to the atmosphere, so that we're keeping that heat pump loop. But for context, the heat pump loop can vary between like 40s all the way up to 80s. So you really have a pretty wide range of flex in there where the heat pumps can be sharing load without turning those pieces of equipment on. The other system that you have in the building is a VRF system. Now, these are not central to the whole building. They're kind of specific spots throughout the building that needed a little boost. This is similar to the heat pump system, and then it's designed to kind of share some load. But instead of using water as your heat transfer, you're using refrigerant. So you have one centralized compressor that's going to be up on the roof or down at grade. And that's an air system that's pulling heat and sending heat out to the air. Then it goes to the branch controller, which is basically just a valve box. It says, where do I need to send things? And then in the rooms, you have your indoor unit, and that defines the heating and cooling of that specific space. So again, they're allowed to have, each of these indoor units can be in either heating or cooling, and they can kind of share that load amongst them. But the big difference is that they're using refrigerant that's distributed throughout instead of water. And those were really just used in kind of specialty spaces or corner offices where the load was going to be a little bit different than some of the other rooms that they were on, to just try to make sure that we were allowing those rooms to fluctuate differently from the building. Turn it over to Matt. Sorry,
Okay.
Casey.
Let's talk construction. So, as Quinn mentioned and Casey had mentioned, the building really hadn't been renovated fully in its lifespan. In the 60s and 70s, they had done some renovations to add air conditioning. And that's what you see here. This is the old jury crit room. It's the current jury crit room. The original building had 2 skylights that were reinstalled in the project. But when they started to leak, the college didn't try and maintain them. They actually just deleted them and put rooftop units over the top of them to provide air conditioning to the building. So we had to deal with rooftop units that were from the 60s and 70s. This unit that was on the 4th floor was from the 40s, and it was about the size of this platform that fed a bunch of other spaces. Yeah.
So I've heard from a couple different people that the as-built documentation situation was pretty lean. How did that like?
For a building of this size?
Yeah.
So as-built documentation in the 30s really wasn't a thing. The documents that we had and these guys built their documents off of. So Casey and Quinn and everyone else who designed this project, there's probably over 400 drawings. The original 1930 set of drawings is about 5. So the entire building was built off of 5 to 10 drawings, if I remember correctly. All of them.
They were beautiful drawings.
They were
though.
great.
Absolutely
The detail
beautiful.
details are wonderful. Find that page.
And I mean, it's over the course of construction, the level of detail that was the standard of care at each time is drastically different. I mean, even the drawings that you get for some of these existing buildings, even when they have full sets, which almost never happens. But even when they do have those full sets, just the level of detail that was expected at that time was really low. There was a lot of onerous put on the contractor to say, hey, this is kind of our intent, build it. And they did. And for the most part, that worked out okay. But now going back into these existing buildings, it can be very challenging to get a good understanding of what's there, because that existing documentation just really didn't exist. And a lot of times, you know, it's shut behind walls. There's really nothing that you can do in a design phase. If it's an occupied building, you can't be tearing open walls. So you have to kind of use the information that you have, try to build in some safety factor, but it's extraordinarily difficult renovating some of these existing buildings, and the older they get, the
More fun.
more challenging it is, yeah.
And at the time, standard construction practices in the 30s and 40s was there was an on-site architect engineer. So RFIs, like we deal with them today, were not a thing. If you had a problem, you drag the engineer upstairs, they solve the problem with you right now. Like there was not a, we don't do that anymore. So that's why there's really not a lot of as-built documentation, because that was not something that really took place in the 30s and 40s.
Was there any for the AC install in the sixties?
Sure, yeah, we had drawings for 60s, 70s. There was a few others, renditions, but they were just additions, renovations of certain areas. So we had great documentation of things that they had done in this area, and then nothing in other areas. So, especially HVAC wise, really just the renovation they did in the 60s was really the largest thing that they had done to the spaces. There were some fire code things that they had done in the 90s, but it was mostly just stairwells and things like that. So, you know, we were dealing with almost competing systems in the existing building, you know, these RTUs. There were, you know, hot water heaters underneath windows. These units that are the air fans that were in the 4th floor, the basement, and a couple other spaces were absolutely gigantic. And they were providing too much air in spaces that were close to them and providing not nearly enough air in spaces that they were trying to feed it toward the end, which is what Quinn was talking about with the VRF system. It was not meant to heat or cool the building, it's just meant to heat or cool those spaces that are kind of at the end of the system. So as Quinn touched on, this is our new system being installed. You know, these are the LG units on the roof. Just another one of the rooftop units. This is the branch selector on the 2nd floor that Quinn was talking about. It looks really small in the picture and in the drawings, but it's about a 4-foot wide piece of equipment that we have to get service to. It's also about 14 feet in the air. So that's a fun wrinkle. And as Quinn was talking about, these older buildings are not meant for all of these new things that go into them. All the additional piping, all the additional ductwork. So we had the ability of very high ceilings, but because of the SHPO review, we were expected to keep very high ceilings in most of the areas that we were working in. And so we were working in very tight spaces to get everything together. So we had a lot of systems on how we were going to try and handle that. One of the biggest that we worked through is coordination drawings. We did an extensive 3D BIM modeling system that was put together for every floor. This is the 4th floor. It's a little blurry because it has every single duct run, piping run, electrical conduit above 3/4 of an inch.
Yeah.
And all the walls and everything else modeled right into it.
I assume that when you guys were making this, then these are all individual layers, and then that's just the final piece all together.
Correct,
This
yeah.
is the final one that's
That's
all
not
together.
like
Oh, yeah, no, for sure.
But you can
So-
also zoom right down into it and see all the parts and pieces,
Yeah.
and you can turn the different. layers.
This is blurrier than the deliverable that we got because it's like a picture of the PDF or whatnot. So it did look better than this, but even so, you can tell how congested it was. But they set it up so that we use Bluebeam, but basically in the PDF system, whatever you use, you can toggle on the different layers for HVAC, for piping, for electrical, for plumbing. It was all able to be turned off and on, so you could see how different pieces interacted with each other.
But this is all generated from a 3D model, so this is not just 2D layers, it's every single pipe was modeled in 3D. Hence, the building was scanned and modified according to the existing building structure.
Right. So
Um,
this is the version that the contractor put together. So we had our own 3D model when we were working in design. But again, we were working off the limited information we had. So the contractor came in and they scanned the whole building once they were able to demo everything out so they could see what the actual conditions were. And then they took our information, they took the point cloud that they created, and they generated these. And this was what they were able to kind of find clashes, find differences between the design and what was actually there, and we could work through those.
So this final drawing that you're looking at here is the culmination of probably 3 months worth of work, 4-hour meeting every week between myself, Quinn, Casey, the other MEP engineers, the 5 or 6 subcontractors who are all working on this all at once. And we did this for every floor down the building. And what this allows you to do is to find clashes, find for the 4th floor, our fun time was the plaster ceilings. For those of you who have not been on the 4th floor of Marshall Hall, these ceilings on either side used to be sloped and plastered. And like you can see it here, there's 4 columns. That plaster ceiling hid a special secret for all of us, which was it is against the structure, which was not what we had thought it was. So we lost about 2 feet of space on the 4th floor. So the original design was vertical unit heaters on the 4th floor and cabinets, essentially.
10 feet in height, you lost? Okay.
And what ended up that we had to create and what we made were horizontal units that were in ceilings because we didn't actually have the space to provide the units standing up on an isolator that's required for them when they work that they won't shake. So we had to redesign a lot of things on the 4th floor. That's why I wanted to show you guys this 4th floor, because those are the kind of things that you can find during coordination drawings, whether they're BIM modeled, hand drawn, it doesn't matter. Coordination drawings are something that are extremely important. And if you're not doing them on a job, my opinion, you're not doing the right thing. You know, even if your coordination drawing is not perfect, you're gonna find a lot more of your problems here than you are out in the field. And you're gonna spend a lot more time out in the field resolving problems than you are installing work. Based on this drawing, 80% of our Victaulic piping that was installed on the 4th floor was prefabricated. So.
And, you know, Matt said they take a lot of time to create, so you can imagine how much cost that was to the contractor to staff that and coordinate that and make sure that they're done properly. That costs a lot of money, and that's an easy line item to miss at bid. And if you don't have, you know, $500,000 in coordination drawings for a really complex building, you know, that's a very easy oversight that can cause a project to go sideways as well.
But these can also inform your schedule for work. You know, how much can you get done? What do these look like? And what are you creating at the end of the day? These documents are hugely important.
And sequencing as well, layering of work is very important.
So construction constraints, Quinn had a picture of it, but these are a couple of my favorites. This is on the 4th floor, and this is one of the water furnace systems. And this is an extremely tight system. You can see a kind of picture on the side here. So these have a supply and return in the front, and they have to have a certain amount of space to get to them. They also have to have this vibration isolator, if you will. And what we also learned in the submittal process is that units over a certain size have a water side economizer, which was not something that anyone new. So most of our units actually came in about a foot larger than they had been designed for, even in our coordination drawings. Because of something that the manufacturer did not just tell the contractor until everything was ordered. So we had a lot of things that we had to work with. But trying to fit these, there's about 86 of these units throughout the building. Most, let's say about 3/4 of them are vertical, the other quarter are horizontal. And it took a lot of time to make sure that these closets that were built actually fit them. They could be serviced because they all have their own filters, they all have valves. They need to be maintenance, they have isolators that need to go under them, so making sure that these closets essentially could fit these units was something that we struggled with a lot, and that we had to, I won't say redesign, but we definitely had to adjust some of these, adjust their location. And, you know, working through that is something that's difficult. And, you know, I have this picture here to show our ductwork. So my job as a construction manager, I'm not a designer, I'm nowhere close to that. So when Quinn puts, you know, this is a 12x20 duct, I can't change that. That's a certain amount of CFM that needs to go to a certain place. But what we can change is if I need to get through this structural beam, which is what that is right there, I'll get into in a minute. It's easier for me to thin this ductwork up, but there's a ratio that I have to follow. Quinn designed a certain amount of CFM to get from point A to point B. So I can't change that size, just neck it down and make it fit what I need to fit, because now I'm not gonna deliver enough CFM. So I have to work with someone like Quinn to tell me, if it's 12x20, what can I blow it out to make it thinner so that I can get through the space that I need and still deliver the amount of CFM? You know, these are everyday problems that we encounter, work through, and it's not difficult, if you will, but it's hard. You know, like I can call and have an hour-long conversation with Quinn about this piece of ductwork that we need to adjust. And it's something that we can resolve very quickly, but it's something that has to happen every day. And I have this picture here to show you guys that we went through in the basement level. Because one of the first conversations that Casey and I ever had about this job was that we cut holes in the structural steel in the basement to have ductwork go through it to keep it above the ceiling.
Which is rare. I got on the job midway
Super
through
rare.
construction and I went, what is that? They never like.
It was my idea. It was my idea.
Yeah.
Walked through, just cut all the holes, in her background is structural engineering. She's walking with me and she goes, "Why is there a hole in that beam?" And panicked for a good minute. But what we learned is, what I learned, this is new to me, you can put a hole in a structural member in the middle third
In both directions.
in both directions. I'd never done that before on any project ever. And so there's like 8 of them in the basement floor, 8 holes through the structural grooving that you can't see because it's above the ceiling. It was a fun week. The steel they cut out of there is pretty large. So I wanted to toss on here something that is important for all of you as construction management students. Communication and, you know, showing the owner things is extremely important. So what I have over here is, I call it a work tracking drawing. Every color on this document, it goes up to one of these areas down here. So we made these weekly. We would track everything. We would send it out in the daily report. The owner gets to see how much progress is happening every week. And I have one of these for framing, electrical, plumbing, mechanical, fire protection, floor finishes, everything. It's a simple way that you can show your owner what's happening when it doesn't have to be perfect. You can see I used a design drawing, even though that's different than our coordination drawing, because the intent is to show how much ductwork has been installed, not exactly its location. Accuracy, not precision. And then we have our standard communication with the architects and engineers, which is RFIs, emails, coordination, all those things. But on a day-to-day basis, there are gonna be times where we have to do something like this. So I drew this, and then what the problem was, and Quinn alluded to it, we had to hide some HVAC in the auditorium. there is an open plenum underneath the stage that has about a 72-inch by 40-inch piece of ductwork that just draws air underneath the stage. And there was one 32 by 40 vent. in the front
Yeah,
of the stage.
they opened up we were supposed to have a bunch of grills kind of in the front of the stage hidden, like, you know, matching with some of the historic detailing. But when they opened it up, there was some structural members that we didn't know about that basically blocked the top half of the entire stage. So all of a sudden, we didn't have the free area that we needed for that air to be drawn into the plenum. And this was the potential solution or the implemented solution where we basically had the risers with like a built, not really grill, but like open area so that that air could be drawn in so that we could make up that free area that we had lost in the front of the stage.
When we turned the unit on, it was drawing so much air that it was actually whistling in the auditorium, which in an auditorium is not what you want. So, we had some existing grates from old vents in the auditorium that were not being used for anything. So, you know, Casey came and did a site walk. I walked with him, we talked about it. I made this sketch. I texted it to Quinn. And kind of gave her the approximate number of these with the size and how much airflow we could pull through it. And she was like, I think that'll help. She goes, I don't know if it'll get rid of the whistling problem, but I think it'll help once balancing is done. And so we have two of these, both staircases are the same. At the end of the day, all the grates were painted black and they have a fabric on the backside of them so that they act as a filter. And we were able to get the amount of airflow that was needed without compromising Casey's architectural design for the auditorium. You know, these are incredibly important, and it didn't cost us anything to do this. We had to build these risers, we had to build this staircase. It took me 2 hours to work with the contractor to figure out a way that we could do this without adding a lot of costs.
Are there individual wrench connections to each of the grills, or is it just like?
No, not in this case. For a lot of the building, there is, but for this case, there's basically just one open duct it's called like a plenum return. So it's drawing air from all of the surrounding space, which there are grills and it goes through that grill and just all comes drawn into that central duct.
Because it's drawing so much air, it just pulls all the air from that area into it. You see it a lot in older buildings with like an old drop ceiling. They'll have a few vents in the ceiling and then there's just like one big piece of ductwork at the back of the room that's pulling all the air above the ceiling.
Which is still done in a lot of designs. It's just a different way to get to the same place. There's different constraints and things that you have to think about when you're doing those types of things, but it still works. So it just depends on really what the goals of the project are and what the ceilings look like and things like that and what your constraints are for those specific spaces.
So we'll go through, we have a handful of kind of the finished spaces. This is what did they call it, Casey?
Well, it's graduate.
Is this Jeeps?
Grads down in the basement.
Yeah.
Yeah, it's just grad offices, yeah.
So originally it was the soils lab, and this is, you can see all the mechanical that was there. This is one of the areas where the ductwork is actually running through this soffit right here. And there's a couple of areas where we have the holes in the steel here.
Yep.
Everything pretty much runs in this soffit and then branches out so that we can keep as much head height in this area as possible. The basement had low ceilings to begin with, so we didn't really have the opportunity to drop that anymore. Conversely, on the third floor, we really kind of celebrated, if you will, all the mechanical in here. Everything gets painted, everything is out in the open. We have high ceilings, there's sound deadening in here. So the idea was, let's just give as much room as we can. There's a lot of space, let's use it. The ductwork, again, it's all painted, everything it has that industrial feel to it. You can see all the ductwork, you can see all the mechanical. And it's a very different feel. This whole area was not just one big room, it was multiple spaces that were opened up to create the large studio. So this is the auditorium Quinn alluded to. So these are the supply grills up here that she was talking about. The plenum is actually under the stage, kind of right back behind the proscenium. This is called the proscenium. And it's right under there. So, you know, what we had to do here, the original HVAC system had grills that were up in this hidden pilaster that was disconnected and now didn't work. So we had all of this is all supply from the fourth floor feeding into here, and then we were pulling everything down through here. There's existing ventilators that were replaced for heating purposes underneath the windows. And this space is actually built in such a way that it is its own building. So getting the electrical and mechanical systems from one side over here from the existing building to the auditorium was a monumental task that the coordination drawings helped with greatly, because there were two 2-foot thick wide concrete encased beams that basically cut everything off on the second floor, because this is its own structure, essentially. So Casey and Quinn went through a lot of renditions of what the ceiling was gonna look like. We were gonna get ductwork places. The amount of conduit that you don't see is amazing. I mean, Casey, how many times, I mean, at one point we were doing blocks on the.
Yeah,
coordination
so we
drawings.
had a rule with the coordination drawing that anything under 3/4 inch conduit, we weren't gonna show in the BIM model. In retrospect, I wish that we had, because we were talking about hundreds and hundreds of 3/4 inch conduits. So if you add all those individual 3/4 inch conduits up, you get to a bank of 4 feet wide by 2 feet thick that you now have to jam through the building somewhere, somehow. It was massive, all emanating from the basement and then working its way, snaking its way through the entire building. It was crazy. Yeah.
And that we started actually on the first floor, I think was where Casey finally asked them, you don't have to show me each individual conduit, but when they're banked together, I need you to show me a bank of them.
Yeah.
Because on the first floor, we have coming across from one side or the other of the entrance to the auditorium, there's probably 50 or 60 conduits that are above the ceiling that we had to try and fit in that small space.
Yeah, the further you are from the electrical room, the more it's just a few one-offs, you know, you have your final runouts. And so we had started on the fourth floor and worked our way down. So on the fourth floor, not a big deal. You have a few 3/4 inch conduits. They typically just kind of route those in the field where they end up making sense. But by the time you get down to the lower floors where the electrical room is, all of a sudden you've collected all of those conduits together and it becomes a massive amount of space that's required to host those.
In a situation like here where you essentially lose supply grades or lose like some area of supply grades, would you have to resize your equipment to maintain that CFM? Or
So we didn't do any resizing of the air side. You could do that, but the problem is you're now changing the load that you're able to deliver to the space. So unless you had some alternative to combat that, typically it's not your equipment that's changing. It's just your distribution from that equipment and how you're getting it into the space. You might have to come up with a different path, a different area. Maybe you add one in a different spot that's less problematic. So it's really more about that distribution between the equipment and the end.
So the ductwork that feeds these grills right here, for those of you who've been to the third floor there are 4 large ductwork pieces that run around the side. 2 of them feed that space. 2 of them run down to here and feed this space and continue down and feed them, partially. Anything you guys want to add for any of these? I'm just sort of running through them.
No, I think you just rip through them.
This is actually where I met my wife, right over there in the corner. This is the first floor, gallery. It was originally the studio, actually originally it was the library for the school. So, when we demoed the old floor, you could actually see where the rack attachments were underneath the floor. There was a dumbwaiter in here right about there in the 30s, and you can see, there was a slab infill when we took up the floor. So this was part of our SHPO problem that Quinn was talking about. The first floor that Casey was talking about was where we had most of our architectural value that we were keeping. And the main architectural value, other than the woodwork that we were keeping, was the high ceiling. So this floor is essentially cut in half right down the hallway, because there is no ductwork that goes from one side to the other. There's piping, there's conduits, but there is no ductwork that cuts across this corridor because we did not have the room. The original plaster was so high to the ceiling that there was no way to get any ductwork across. So this was a fun exercise in how we turned ductwork up on end to get it through these soffits that you are on the other side of this.
Yes, yeah, the soffits, those were very congested, yeah.
So is the alternative ductwork, fed up from the
Right.
roof or in from the walls? Or-
Yeah, so basically what we did is we fed down on either side. So we have ventilation ducts, so the ventilation units are up on the top floor. And that duct has to get throughout the whole building. So there's risers on both sides that come down, actually both sides and both ends, that kind of feed out to the spaces. And then you have the heat pumps, which are in or close to the areas that they serve that have their supply and return duct that are more limited, just going in that one little zone.
So this side of the hallway, there's a heat pump closet in this room right here that has a heat pump that feeds this area, and then another one that comes off and feeds this whole area. Same thing on the other side. So you have 4 heat pumps that feed this part of the floor, and then when you go to the other side, you have similar number of heat pumps. Some of them are on this floor that actually go up to the second floor. That was more uncommon. But again, we had about 85-ish heat pumps throughout the building. So pretty much every heat pump was feeding 1 to 3 rooms.
And that's why in those studios, you see the breaks in the big circular duct. It's because each of those are separate heat pumps. So each of those runs go back to a separate heat pump in a separate zone.
This is Nifkin. So you see the historic photo. It was kind of a dark, dingy place, especially when I was here, doing my overnights. It was a good place to sleep. Now it's a lot brighter. We were able to fit conduits and ductwork through here, but most of the mechanical is fed in this back room here. There's another one over here, and then supply ductwork is fed through 2 existing foundation wells that went from back to front of the entire Nifkin lounge. They were originally hydronic piping that went up to all the water heaters. We abated them. We put ductwork in there along with conduits and some other piping, but that is where all the supply ductwork is fed on both sides of the Nifkin lounge, and the heat pumps are back in here and back in here. So it was a really interesting way to hide the ductwork and the mechanicals. It was a very difficult thing to
It was
do.
a very difficult thing to do because they're in, basically trenches, and there's times of the year that they were getting water in those trenches. We had to be careful about what materials we used. We had to be careful about the elevation that we were putting them in there. We had some special plastic ductwork basically that we were gonna put in there, and it became problematic in the construction because they just couldn't get it. This was right around COVID time. There was a lot of material problems that we were having getting things on site. And all of a sudden we found that, hey, that fancy plastic duct that we really wanted in this space is just not going to be available in a way that's conducive to the construction schedule. So we ended up going with welded stainless ductwork, which is uncommon in an application like this, but we wanted to make sure that it was robust enough to deal with any humidity issues that we would see in those trenches. But that's a process to weld a piece of duct in a trench and have to spin it and all that. So it was a bit of a headache, getting that put in and getting it in a way that is gonna be good for the project.
What we ended up doing was, so Quinn's alluding to, we were originally gonna use fiberglass ductwork, but to do that, you have to glue it in a slip drive system. You have to let it set, and then you have to fiberglass over the joint so that it makes a continuous ductwork. It actually has to be sanded. It's very time intensive. And with everything happening in the world, fiberglass was super expensive. It was actually cheaper to do the galvanized, or the stainless steel, I'm sorry. But to do the welding part of it, everyone thought we were gonna weld it inside these trenches. And we didn't do it that way. We ended up welding them all the way across the floor, and then like a straw would just fold it in.
Yeah, originally the design like turned in the back of so it came out and it kind of turned. And they said, well, there's no way, we're not able to do the welding the way that we thought. So we took off the turn and then just made it, and then just kind of moved the grills a little closer together and evenly spaced so that we still had the same capacity. But they were able to then weld it outside and drop it in instead of trying to deal with the field welds.
The big
Around the
straw,
corner.
you just lifted it up.
Yeah.
It was quite the process. But it was really cool. It's actually something I have not done since. But then again, I haven't put a lot of ductwork in a foundation slab. And then this is the second floor, that main vestibule area by the, elevator. Again, another dark space. There's so much ductwork up here that you don't see on both sides of these hallways. You know, the hallway is actually something that Chang O'Brien came up with. So this was, as you can see right here, there was one hallway and then it was large classrooms and then smaller classrooms. So during the design phase, like Casey alluded to, they were able to come up with how many offices they needed and design in another whole hallway on this side over here, which allowed us a lot of room to put ductwork. This was actually the most space that we had. These are 9-foot ceilings, Casey?
Yeah.
And to deck was like 14 or 15 feet. So we had the most amount of room to cram stuff in here and we took advantage of it. So it's an interesting layout, a lot of things that you don't see that have to fit into this space. And in a historic building like this, it takes a lot of time. You know, Casey and Quinn were out here every week, working through problems with me and the contractors. This is the second floor, old balcony. It's now a conference room. And again, this is, you know, we had talked about how the auditorium was sort of its own structure. And these right here are the beams that go across that are concrete encased that kind of cut it off from the rest of the building. So we were able to bring plumbing and the mechanical into this space fairly simply, but it made a huge dramatic change to how the space was originally used. You know, I used to sit in my art history class right there. And now it's this beautiful conference room that you guys get to use. The professors get to use. I don't remember how that's done. And then the jury crit room. So this is the existing new jury crit room. This is the pyramidal skylight that we put back, which has electrochromatic glass in it. And self tints based on solar gain. So as Quinn was talking about, there's a lot of things HVAC wise that we're trying to work with and mitigate. And when it comes to something of this scale in glass, solar gain is a real problem. Somebody sitting in this room can be really hot, even in December on a sunny day. So we worked through a lot of different things with the ductwork, how it was aimed, how it was fed, and the glass here is working to create enough heat, but not allow everyone to bake in the sun. So it goes, watching this get tested, you can go from 99% tinted to 0% tinted based on a controller that's on the 3rd floor. You can manually control it. You can have it set to a setting. You can change it on your phone. That guy was way too excited about it. Who did all the training? I think that's everything. Any questions, comments, angry rebuttals?
Was there any cost overrun, like, from my perspective, like, after hearing you guys, the contractor or the owner cannot guess about the structure firsthand when they are like advertising the contract, even like you have a good consultant working with you, cannot get into too much detail about existing structure and existing features. So like the contractor could be a disadvantage, like you paid some rough number, it could go up like.
Oh, yeah, absolutely. Change orders are a real thing, and that was certainly a thing on this project, absolutely. So one of the things that the state does is, they're required to take what they call the lowest responsible bid.
Yes.
So they're allowed to review those bids and make sure that they're not, you know, if there's one that's just millions and millions lower, they'll go back and they'll be like, why? You know, I think you're missing things, you know, justify why you're so far off from everybody else. So they have some ability to have discretion with hiring, but they are required to take the lowest responsible bid, which means whoever comes in on bid day is the team. You know, and they don't have control over which contractors are picked for that project. And there's a variety of contractors out there, from people that are really, really great and know their stuff and honestly will fix problems in the field and not even tell anybody because they are super capable, all the way to folks that are less so.
They're gonna do anything.
Yeah, yeah.
But the
So-
contractor is entitled to more money if they find field conditions that nobody could anticipate.
Right.
Oh,
It's
yeah.
not something like you own it now. If they can reasonably argue that this was an unforeseen circumstance and it wasn't documented in the documents, then they're entitled to more additional money to do that work.
Yeah,
To mitigate that, the state takes a lot of work ahead of time. So there were several destructive demolition investigations that were done to try and give everyone the most amount of information on the design team to make the design as accurate as possible for bidding. To try and, for that reason, to try and mitigate those issues. You're never going to mitigate all of them. I don't care what they tell you. I don't care how much work you put into anything. The reason that people hire construction managers is because every job has problems and you have to work through them.
Yeah.
So if anyone ever says, this is the solution to all your problems, just laugh at them.
Yeah.
Because there will be problems on the job that you have to solve in the field. The issue we had on the 4th floor, that was a complete unknown until everything was demolished. And they had even done destructive demo to
We did.
check for that.
Yeah.
But the slope was tighter than the roof was originally thought. So when everything came down and they started doing the verification, little red flag went up. Hey, we don't have enough, that heat pump to fit it, it's supposed to go way back here in this closet that was only supposed to be about 3 feet off the wall. Well, for me to fit it, this room is gonna shrink to this size because the slope of the roof is like this. What are we gonna do about it?
Mhm. And projects carry contingency numbers. They basically have a pool of money that is strictly meant to pay out changes that happen in construction. There's not a job ever that doesn't have a change order. It does that, no, doesn't happen. So there's always something that you find, something that has to be different. No drawing set is perfect, no matter what good information, except for mine, of course, mine are perfect, but.
But for this type of project, contingency of 5% of the construction value. So that's what additional monies on top of what was bid on bid day.
If it goes beyond, will the project be canceled and contract will be voided?
Well,
So, no.
Typically what happens is you start to, as you get into the project, if you get to that, let's say your 5% is 10 million, which I don't know, that would be huge, that'd be way too much. On a job like this, it might be, let's see,
we had like 1.6.7.
so let's say we start getting into it and we've run into enough problems that we've used half of it. We're not even a third of the way through the job. Now we start to talk about, okay, what are we not gonna do? What do we have to change? What is a required change order? And what is just something that people want? You know, like, oh, we would really love these smart boards instead of whatever. But that's a request versus the structure on this thing is falling down. We have to fix it.
Right.
So you start to make those value changes and calls that have to be made, because if you're at that point where there's an existing condition that nobody knew about, designer, architect, nobody knew about it, and you have to fix it, if you find enough of those, you have to start making those value changes, because things that are nice to have versus the building not falling down, everything's relative. You know, another way that we combat change orders is what we call an allowance. So it's a varied amount of money in the contract that for, you know, however much money you can put it together for, there's no change order. It also allows for, in New York State, there's no overhead and profit on that work. So if the contractor submits a change order for whatever it is, they're gonna put overhead and profit on their sub, their work, the labor, the material, everything else. You can strike that out and all you're paying for is the raw number. So you actually get more out of it by having an allowance. And on this job, we had both. there was a field order allowance, and there was a change order contingency fund. And we were able to work through a lot of these problems by using those funds as required. We started off with the understanding with SUCF that the contingency fund was for required problems. Once we found the issue on the fourth floor, we kind of had to fall back and punt with some things that were happening that were some wants that the campus wanted. And we said, okay, well, we need to pause that, because right now we need to work through these things, which we have to do.
And another big hit was the existing copper louvers on the outside of the building were found to be completely rotten when we pulled everything out.
Not the copper.
The copper sills where the wood behind holding up the copper was rotten in the entire building. So I think the change order was what, 300 grand or something like that to just fix
Still
those and put new copper sills on. Nobody saw that money coming or accounted for that money. Yep.
There was a tank down there.
Yeah, I found that tank right there.
Yeah, there was a tank there. Yeah, that was a field condition.
That was it.
Yeah. So once again, the contractor was entitled to money to remove and remediate that tank.
So that was an old diesel tank. In the 30s, when the building was built, the basement of Marshall was can't get to it quickly, can I? The basement of Marshall was where they housed the campus's fleet of vehicles and where they maintained them. So the road around campus, this was actually a road until the 50s. And this overhead door, which was a double door for a while, this had all the fleet vehicles in it. And so it was an oil water separator that was underground that was buried and no one knew about it. In fact, there were no documents of it being installed, removed, disconnected, connected. No one knew it existed. The UL listing on the tank was actually hammered copper plate from probably the early 30s. So we were demoing some things down here. We found some really cool stuff. We found about a 4-foot round stump in the ground that was under the road that was completely black because it was buried about 3 feet in the ground. So they just shoved it down until they paved over the top of it. And I actually came around the corner when they pulled the tank out of the ground with the excavator because he bucketed down and then pulled and the whole tank came up out of the ground and bent it in half when he pulled it up. And that was a fun day. I came around the corner and that happened and I immediately just went, whoa! Everything ground to a halt for about a week in this space. But that was interesting to find. I think I left it for Rex, the copper
Yeah.
UL listing. Because you could tell it was hand hammered because on one side it was deeper than the other.
Did you ever find, where that fed into the building? Cause I've seen all the locations and like some of the reports and stuff, but like, I was at and I couldn't really figure out, did you find where it fed into the building? Obviously, there
We
was
did.
complete bay, but,
We
like,
did. So the tank was kind of right here. And we found some piping that came out of it that went just under the slab by that man door that was over here. And they stubbed through the slab and then were cut. So we don't really know where they went after that, but there were 3 of them that went kind of spidered a little bit and then into the building. So to remediate that, we have to have a contractor come in who specializes in that. They pull the tank out, they have to dig the soil out until they get clean soil readings, and then that soil has to be replaced. So we had to do that from the area over here all the way to where the piping hit the building. And then we had to make sure it was all gone. The tank looked like it had been shot with a shotgun, like a bird shot. There were just holes all over it. So there was water in it. We assumed it was water. It had to be pumped out. We had to remediate the soil. And we had to put the soil back. It was a fun process.
But just on the architect, engineer side of things as construction managers, Matt was incredible to work with just because of the level of communication and his ability to proffer. So a lot of times construction managers come to you and say that here's the problem. Matt would say, here's the problem and here are 3 potential solutions, as opposed to just saying, here's the problem.
Yeah.
Which is very, very important. You know, think about the problem before you just bring it to somebody.
Not on this day.
Yeah.
I didn't know what to do on this day.
We just paid money. That's what's going on. Yeah.
What about asbestos?
Yeah, we ripped out a lot of asbestos.
Oh, yeah.
What would you like?
Yeah,
I assume there was. You guys have.
massive amounts of asbestos. Yeah.
We
Yeah, and do you have any idea about like what portion of the cost will actually be that?
Abatement?
Ooh,
I'd have to go back and look at the SOUs.
I don't, yeah.
I'm sure.
I mean, I'm sure it was like 5%, 6%, if
Yeah,
not more.
And so we found out as we were doing the project that. So originally Marshall was used for several different things that it is currently not used for. The top floor, this, you can just see the old skylight that we put back on the 3rd floor. And the one on the 4th floor here, the one on the 4th floor, that was the old soil slab. So they took a soil table and put it up on the 4th floor, covered it in a foot of soil, and that was, they used the light to do all their soil work. So we found as they were building this, the intent of the project became different. And also the state ran out of money, because we found behind every single wall that was existing, a sink setup. There were copper pipes that were fed for hot and cold and a drain. Most of them were plastered over and capped, but the intent was just about every single wall could have a sink in it, and nobody knew. Yeah, Rex had no idea. I mean, we found them everywhere. Every wall had just piping for no reason.
But abatement probably took, what, 8 months?
6 to 8.
8 months of time to
And
start
part
to
of
finish?
design is doing a survey, so you have someone come out and like make, try to identify every source of abatement, which, is impossible, but, we do our best and whatnot to document that, and then, with buildings this old, always. I mean, really, up until the 80s, 90s, I mean, it was very pervasive, so it's still a part of almost every project unless it's been previously.
But it's also the state stance to remove it, we never
Yes.
encapsulate it whenever it's found. So wherever it was found, we paid money to remove it. So it
Yeah.
was quite a,
This building was never gonna burn down.
Yeah, yeah.
The trench that we were talking about that we ran that HVAC piping in was about 3 feet deep and 3 feet wide. It was filled with piping that had to be abated. And now that trench goes, you're in Nifkin at the very back where the stained glass window is, going all the way from there, all the way to the doors, and then there's a closet off to the left. That's where it started from. So to abate it, our abatement contractor had to crawl through it with no access, except for the 2 ends.
You
And they-
crawled through that trench?
And he would cut out a section,
Oh,
and they would crane it back, because that's the only way to get in there. So we had to do that safely, OSHA standards, you have to have a rescue line. So there was one guy who would crawl through there, and he would cut out a section of pipe and then throw it back, and he had a harness on, and somebody's job was to just stand there monitoring the air, and in case he needed to be rescued, and be back. The things that I saw in those pictures those guys sent me of what they found down there. We found some really cool things, in the auditorium, when we pulled the stage front off, we actually found a hand-drawn etymology card. So they had on one side, hand-drawn pictures of the insect, and on the backside, cursive writing of what it was. And we found about a stack of about 6 or 8 of them. I turn those over to Rex too. We found daily oranges from like the 40s and 50s that had been stuffed in the wall as insulation. We found a full 6-pack of beer on the 3rd floor under the floor that was not open. We tried to get one of the electrical apprentices to paint one for a few $100, but we didn't do it.
Smart man.
Listen, these are the things you gotta check.
What's the current state of like, as the drawings or 3D scans for these projects?
let's
Like,
see
how
those
do
CAD
those are-
files.
The BIM
You have questions online?
was.
Yeah, so yeah, the BIM model was turned over to the campus, so they actually have the BIM model that we created during design. So that they have a record of what was there.
And they have all the as-built drawings from the contractor as
Right.
well. The contractor was responsible for modifying the drawings
Mhm.
and giving the campus pictures. Yes, we have a lot of pictures.
There's an entire,
Yep.
so SUCF has a very intensive spec about documentation during construction.
Yep.
So there's an entire website essentially of thousands of photos, plus I took photos every day, daily reports, hundreds and hundreds and hundreds of photos that I'm required to turn over to the state.
Yeah, it's like an annotated PDF document that you can click on a dot and it brings up kind of time lapse every 2 weeks or so, a 3D view in the room, which was great to go back and say, you know, this pipe was in the wrong place, instructions, this pipe was in the wrong place, this valve needs to be turned on, like things like that. So
And at the end of.
full documentation.
To start the job, we had to do an existing conditions walkthrough, which was a video of the entire building. And then at the end of the job, we did a new conditions survey, which was a video of the entire building. So you get all of that, the state gets all of that information. What they share with the campus is, I think, just about everything.
Everything, yeah, campus.
They want, they get.
We had to do a as-built BIM model,
Mhm.
which I know you
Yep.
guys were working.
Yep.
with.
Yep,
Yeah,
yep.
Yeah.
So if there's no more question, I just had one question about the energy retrofit aspect of the work. Did the project have any sort of like energy reduction goal?
Oh, yeah,
So what was-
absolutely.
What was that?
Oh, man, what was the actual goal at the time?
so this project was achieve LEED gold.
Yes.
LEED gold,
Yeah.
yeah.
Okay.
Yeah, so we
which
did
is
achieve
great.
LEED Gold, and the state has kind of benchmarks for, depending on what type of building, what it is that you have to hit. I should learn that
Ah.
number offhand so that I can answer that question in the future, but I actually don't know
So we did
offhand
we
what
did
that
a blower
was.
door test
Yeah.
at the beginning to start the job, to set that baseline of what the
Yeah.
building was,
Mhm.
which is you essentially.
Baseline before the renovation.
Yep, so we
Okay.
basically
Yeah.
over pressurized the whole building and then read out what, I don't remember what it was, but I was here for it. And then we did it again at the end of the job.
Very
and-
nice,
And it's like it's a difference.
Yeah.
Mhm.
You
In
need
the
to
anti
be
of
above,
the building.
yeah, you need to be above a certain difference to get the different qualifications. What the number is.
Oh, that's fine.
Yeah.
That's good.
That's
But yeah,
math,
energy
it's
was
way
a
low.
huge focus of the building,
Yeah.
so it was something that we tracked all the way through. There's a lot of controls in the building that were not there before, so that they
Right.
can kind of both track and control the building. We have LEED Gold certification, which was something that was really.
So
important to
for
campus.
the energy conservation measures that you mentioned you used, in addition to the mechanical
Mhm.
system aspect of the work, because of the historic value, apparently you didn't use any, or you didn't add any exterior insulation.
Yes.
But did you add any interior insulation?
So the reason that we didn't add the exterior insulation had actually nothing to do with energy.
Mhm.
It had to do with the performance of the wall. So because it's multiple wides of like masonry construction, you worry about when you add insulation on the front face, you can have moisture problems through
Condensation.
that.
Yeah,
Exactly.
you change
So-
the dew point of
Yeah,
the wall.
Right,
Yeah.
so the reason we didn't end up doing that is because we did an analysis of the wall and we found that if we insulated, that we were gonna start to cause problems. Right, so even though energy, and that's one of those things where you kind of gotta balance your different
Very good.
constraints. Because energy wise, it would have been great, but if we're causing construction issues in the wall, that's certainly not something that we want. So the only place we insulated is where we pulled out those louvers.
Yeah.
So we did insulate there because we had control over that construction. But the rest of the building stayed uninsulated to protect the
So we have,
masonry.
it was actually an air gap. The thought was, we're heating this space is unheated, you have about 1.5 foot of masonry. So we have a 2x4 furring off the wall. So that air gap is actually your insulation, because you have heat coming into it and out of it.
And allowed us to run conduits as
And
well.
allowed
Yeah.
to, with that electrical gain, it goes through. So that was the thought there, and as far as I'm concerned, that was tough to do. Trying to get some of those things together, and clearing off the wall. The amount of times I was asked why the walls weren't insulated, I could probably have retired. But yes, that was the discussion several times, and we can insulate whatever you want, but you'll probably have water running down the inside of the building. Were there any other questions?
So like, assuming that there's like a spider web network of communication over everybody here, is there like, was there like especially high communication traffic between the three of you? So like, or was it like specific to the project that was the case, or like, is that a conventional thing? Because obviously, it makes sense that like the three of you like, on a project would be talking to each other a lot, but like, would you say it was like a conventional thing that y'all ended up like clumped, or was it like something specific to the projects that happened to you guys?
So yeah, every project has a different team basically, and the level and method of communication is gonna vary based on those individuals. You know, there's a standard procedure that deals with submittal exchange and RFIs, and those are all contractually documented, timed processes. Now, on projects where you have, I would like to say, great team members that are willing to work together more closely, like, you know, we had group text messages, where we said, hey, this is coming up and whatnot. Now, you have to be a little careful with that because that's not a contractual document. So email is a contractual document, text message is not. So it's, you have to find that balance where you're documenting anything you're talking about. But in something like this, where we were really trying to get some real-time answers and whatnot, there were times that, you know, just pick up the phone and call. And, you know, we were down at site quite a bit.
Yeah, I mean, generally our stance is construction takes priority. Like from our, you know, if somebody is waiting on site for an answer, we generally do our best to prioritize that as an issue where we can
Yeah.
and get answers back. where we
The
can.
amount of communication that the three of us, we got tossed Quinn.
Yeah.
And we brought Quinn up to speed as fast as possible because she was brought in to just help with some problems. And then a year later, she was running the job for her office. So the amount of communication that the three of us had is maybe a little bit unusual just because we all got along really well. And so like, we text all the time during the project, and since we don't get to talk as much anymore because we don't have YouTube, but we all still talk pretty much, you know. Casey and Casey started skiing during the project with his young son. I ski with my daughter, so we still text every now and then about that. We've gone to a couple of concerts together. So, you know, on these jobs, you can find and make good friends.
Yeah.
But I would also say this project had a lot of issues, So that's
Yeah.
just,
I mean,
we were talking a lot, so.
there's construction jobs that I visit almost never. There's jobs that I am there in the beginning and then I'm there to punch. I'm communicating with people along the way, but I'm really never on site. Because of some of the like unforeseen issues and like just some of the troubleshooting that we had to do on this project, I was there a lot. So there's really a huge variation depending on the project and the complexity and the issues that come up with how much that happens in the field.
Very good. Let's get back to our speaker.
Thanks, guys.
Thanks a lot. Great job. It's fun. Thanks for having us. Thanks so much. Very nice.
Do you have my phone number? You could.
Yeah, for sure.
I'll
see you guys later. I'm gonna go check.
Yeah,
Yeah,
check on
yeah.
your son. Hopefully that's what you were.
Great, that's great, very good.
So my number's.
Yeah, we do journals, coming in,
Very well.
Yep. A lot of manufacturers.
Oh yeah, we probably ran your class long, didn't we?
No, that's fine.
Talk all day.